My name is Gaby Marquardt, and I'm heading our Global Clinical and Technology Innovation Department at Siemens Healthineers Laboratory Diagnostics. In Predictome, my team and I are involved in Work Package 1. Work Package 1 will focus on improving the access to biomarkers for the early detection of cognitive decline.
My name is Johanna Mitterreiter. I'm a project lead at the Clinical Technology Innovation Department at Siemens Healthineers Lab Diagnostics. In Predictome, I'm leading the Biofluid Biomarker activities.
My name is Verena Pikulski, and I'm a lab technician at Siemens Healthineers. My role in this project is processing the samples, both dried blood spot cores and venous samples from the different sites.
Alzheimer's disease remains one of the greatest medical challenges of our time. With the first disease-modifying therapies available, early detection has become our greatest window of hope. Fluid-based biomarkers offer a minimally invasive and easy and scalable solution to detect the disease early. Especially blood-based biomarkers have recently shown to have a very good correlation with the underlying pathology in the brain.
A blood-based biomarker is actually something you can measure in the blood that tells you something about the underlying disease. So it could be, for example, a protein, but it could also be any other molecule that you can detect in the blood to make a better diagnosis or a better therapy decision. Currently, there's a lot of global research focused on finding better ways to detect Alzheimer's disease early. Scientists are studying digital tools, imaging, but especially also blood tests.
Blood-based biomarkers have several advantages. They are minimally invasive, highly accessible, and fast to obtain. Blood sampling requires only small volumes of blood and fits easily into routine clinical workflows. Furthermore, blood analysis can be fully automated on high-throughput platforms, enabling the measurement of thousands of samples per day.
The most promising blood biomarker right now is called p-tau270. And it's actually beginning to enter clinical practice. It rises early as Alzheimer's pathology develops, even before symptoms appear. It also strongly correlates with changes seen in brain PET imaging and cerebrospinal fluid markers, which are the current gold standard for AD diagnostics. Alzheimer's disease is a highly complex disease that can present very differently from person to person. And it often actually occurs alongside other conditions.
Predictome shows how blood tests can be combined with digital tools and clinical information in a step-by-step screening process. These novel biomarkers will help to identify people at risk early.
What excites me most about the biomarker work in this project is the strong collaborative approach, where each biomarker contributes a distinct piece which ultimately comes together as a bigger picture. The close collaboration between industry and academia brings together strong science and real-world impact, which makes the Predictome project very fascinating.
Looking forward, projects like Predictome, therefore, will enable early detection of Alzheimer's disease at a very large scale.